All right, we're going to prove this inequality here for every integer n greater than or equal to 1. And we previously proved this equality here, and we're going to use this equality in order to show this inequality. Before we get started though, from this equality, this implies that 2 times 6 times 10 for n minus 2 times n factorial is equal to 2n factorial. So this is going to come in handy in our proof. Okay, so let's go ahead and start our proof by principle of mathematical induction. We're going to do our base step. Consider p of 1. So that means we're going to look at 2 to the 1, 2 to the 1, 1 factorial squared. And of course, that's just 2 times 1, which is 2. And then over here, 2n factorial. So that's 2 times 1 factorial, which is of course 2 factorial, which is 2, right? So this checks because 2, of course, is less than or equal to 2. So let's go ahead and do our induction step. Suppose P of k is true. Thus, we have this inequality is true for some k, right? So 2 to the k times k factorial squared is going to be less than or equal to 2k factorial. Let me make sure I got that right. Yes. Okay. So now let's consider 2 to the k plus 1 times k plus 1 factorial and then squared. All right. So we know this is equal to 2 times 2 to the k. That's the same thing as 2 to the k plus 1. And k plus 1 factorial squared is just k plus 1 factorial times k plus 1 factorial. Okay. So this is equal to, all right, so I can rewrite this as 2 times 2 to the k times, so I can rewrite this as k factorial times k plus 1. And then again over here, k factorial times k plus 1. And then I can have 2 times 2 to the k, k plus 1 squared times k factorial squared. Okay, so the reason why I did this is because I can use my induction step here. So I'm going to put 2 times k plus 1 squared. And then I can see this is 2 to the k times k factorial squared. 2 to the k times k factorial squared. And I know, right, this is less than or equal to 2 times k factorial, right? So this is going to be less than or equal to 2 times k plus 1 squared. And I know 2 to the k times k factorial squared is less than or equal to 2k factorial. So times 2k factorial, because I know this piece is less than 2k factorial. So this is equal to, so now I'm going to use this fact here. Remember, 2k factorial is equal to this product here, right? So this is equal to 2 times k plus 1 squared times 2 times 6 times 10, but instead of 4n, right, it's 4k minus 2 times k factorial. right? And that, this is equal to this. And then I can put 2 times k plus 1, and then I'm going to do 2 times 6 times 10, dot, 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 4k minus 2, and then k factorial times k plus 1. And I know that's the same thing as k plus 1 factorial. So this is going to be 2 times k plus 1 times 2 times 6 times 10, dot, 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 4k minus 2, and then k plus 1 factorial. Now, I'm going to have to sort of look at what I want, right? I want to show 2 times k plus 1 factorial, right? So I'm going to do a little bubble here and see what I've got, right? So 2 times k plus 1 factorial. All right, this is equal to, so I'm going to be using this product here because this is what I have, right? So remember, it works, this equality is good for any n bigger than or equal to 1, so k plus 1 is bigger than or equal to 1. So I know this is going to be equal to 2 times 6 times 10, dot, 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 4k minus 2, and then the next term, 4 times k plus 1 minus 2, right, times k plus 1 factorial, right? So I know this is true from this guy here, right? Okay, so this is equal to, so let's see, what do I have? So I have 2 times 6 times 10, dot, 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 4k minus 2. This is going to be 4k plus 2, k plus 1 factorial. So look, I'm really close to what I need. I just need 4 times k plus 2 over here, right? So let's start it off again. So 2 to the k plus 1 times k plus 1 factorial squared, right? This is what I'm starting off with, right? Is less than or equal to what I ended with, which was 2 times k plus 1 times 2 times 6 times 10, dot, 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 4k minus 2, k plus 1 factorial, right? That's what I have, okay? So this is equal to, so 2 times 6 times 10, dot, 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 4k minus 2. And then I have this 2k plus 2, right? If I do 2 times k plus 1 and I put it in there. And then I have k plus 1 factorial. And now, look, I want 4k plus 2, right? But for k bigger than or equal to 1, 4k plus 2 is always going to be bigger than 2k plus 2. So I know this is less than 2 times 6 times 10, dot, 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 4k minus 2, 4k plus 2 times k plus 1 factorial, right? I know that's going to be true. And I know this, right? This is exactly what I wanted. And I know this is equal to 2 times k plus 1 factorial. So look, I was able to show that 2 to the k plus 1 times k plus 1 factorial squared is less than or equal to 2 times k plus 1 factorial, right? Thus, I was able to show 2 to the k plus 1 times k plus 1 factorial squared is less than or equal to 2 times k plus 1 factorial. Therefore, by PMI for every n contained in the positive integers, we know 2 to the n times n factorial squared is less than or equal to 2n factorial.